for just a minute, let's pretend we're on a beautiful beach, listening to those waves crash on the beach. It's a relaxing place. But now it's back to reality. We are going to be spending our time for at least the next few weeks talking about waves. And yes, like the waves in the image, all right, we're going to be talking about water waves, but we're also going to be talking about light waves and sound waves and different kinds of rays like gamma rays and X rays. These are all different types of waves that happen in the electromagnetic spectrum. Now, there's going to be a lot of terminology that we need to gather, and we're going to look at how waves carry energy primarily, which you maybe didn't really consider that waves are a way that energy travels from one place to another. Sound also uses waves to travel from one place to another. Okay, light, same thing, going to use waves to travel from one place to another. Now, let's take light, for example, actually travels along a wavelength in order to get from where it is to you. So there's a few things that we need to understand about a wave. And we're going to kind of consider its anatomy, okay, or the parts of the wave. But before we do that, let's break down what a wave is and how it's... Before we do that, let's just take a look at the absolute basics of a wave. So before there's a wave, there's a straight line. Okay, we call that line its equilibrium. It's if there was no wave, where would it be? It's equilibrium. From there, we can then look at how a wave moves compared to its equilibrium. So here you can see I have the equilibrium where this wave was when it was flat, and then what it looks like now. It's important to know what your equilibrium is because we're going to use it as a reference point when we're looking at various things. Now, in terms of the most basic parts of a wave, there are two primary points on the wave that we need to be able to identify. One of them is the crest. So think for a minute, where do you think the crest is going to be on this wave? Crests occur at the top of each of these humps here that make up the wave. The next part of the wave that we want to be able to identify is the trough. Okay, the trough is going to be the lowest part of the wave, whereas the crest was the highest part of the wave. So it goes below the equilibrium. So we have our trough. Now, in terms of measuring waves, we have two main measurements that we're going to use, both wavelength and amplitude. So a wavelength is going to be the distance between two crests that are right next to each other or two troughs that are right next to each other. Typically, we measure them with the crest. So let's take a look at what we have for our wavelength. We're going to go from the top of one crest to the top of the crest right next to it. That is going to give us our wavelength. Now, next is our amplitude. Amplitude can be thought of as the height of the wave. And this is why our equilibrium is so important, because we don't measure height from crest to trough. Instead, we measure height from the equilibrium to the trough or the equilibrium to the crest. So if we were looking at amplitude, I'm going to start, let's say at my trough here, go up to my equilibrium, and here I have my amplitude. So to review, crest is going to occur at the top of each of our waves. Troughs occur at the bottommost portion of the wave. A wavelength is the distance from crest to crest or trough to trough. And the amplitude is the height of the wave. Now, we have to understand these very important four vocabulary words because we're also going to talk about things like frequency, okay, which is how many wavelengths occur in a given amount of time, okay? And by frequency, that's going to allow us to know how fast or slow our wavelength is going. Our amplitude can help us understand how much energy a wave is carrying. Okay, so we're going to start with these basics and go from there.